Okay, now let's do question 3. In question 3, I need to okay, yep. In question 3, I need to write a decay equation, okay, for this process. When uranium 238 is transformed to thorium 234. Okay? So I have uranium 238, 92 before the reaction, okay? And afterwards it becomes thorium. Okay? The atomic number of thorium is 90. Okay? It is given in the test. I wrote it on the board. Okay, and there is a missing element. Okay? So the idea I do it is now the total atomic number before should be the same as after. Okay? So the missing element must have atomic number of 2 because 90 plus 2 gave me a 92. Okay? And when they have an atomic number of 2, now let's find out the mass number. Okay? Same thing. 234 plus a number has to be 238. So the missing number must be 4 because 234 plus 4 gave me a 238. Okay. So the mass number is 4, the atomic number is 2, and now we have alpha particle. Okay. So this is alpha decay. Okay. Now let's move to question 4. Okay. In question 4, we do the same thing. Okay. I have this equation. Okay. I have this element. Okay, let me use red. I have this element. Green. Okay. Gives out a nuclear radiation and become this. Okay. And during the process, it released something. Okay. Now, what I can say is now, the atomic number before, that's the atomic number after. Okay. So the atomic number of the missing element must be -1. Okay. Because 44 minus 1 give me a 43. Okay. And when the atomic number is -1, okay, it must be a beta particle. It must be an electron. Okay. So that's what we're going to do here. So from those information I know, okay, this element goes under beta decay. Okay. And the mass number of the beta decay, beta particle is 0. So the mass number 103 must be 103 here. Okay, because 103 plus 0 give me 103. So this is another equation for question 4. And for question 5, now I told everyone that this particle goes under gamma radiation. Okay. The reason it works is this. You see the little sun on the top. When we have this little sun on the top, it means this certain element is excited. Okay. And when it's excited, it's ready to release gamma radiation. Okay. So after that, it will release gamma radiation with 0, 0. Note that the atomic number of gamma radiation is 0. Okay, so atomic number of the new element must be the same, 61. Okay, because atomic number that didn't change, and the the mass number is going to be the same, 145, because 145 plus 0 give me 145. That's the equation down. Okay. Now, here is the most difficult question. Question 6. In this question, basically what we have is we have a neutron. Okay? And the neutron is written as this. A neutron alone has atomic number of 0 because there is no protons. Okay, so the atomic number is 0, and there's one neutron, so the mass number is 1. Okay, remember, the number of protons plus the number of neutrons is the mass number on the top. Okay, then it goes under beta decay. Okay, so somehow this neutron released a beta particle like this. Then I need to do the math. Okay, so when the neutron releases a beta particle, there must be, well, do the math. Okay, I have -1 plus a number, give me a 0. So that magical number must be 1. Okay, because 1 plus -1 give me a 0. Otherwise, the equation is not equal. Okay, down. Look at the mass number. 1, 0, so 0 plus 1 must give me 1. So the mass number must be 1. Okay, so now in your exam, if you put down x, if you have the atomic number and the mass number and you didn't know what it is, I give you full marks. Okay? But actually, let's think about this. Something that has one proton only, because the mass number is 1, so there's only one proton. It's basically a proton. Okay? So during this process, what's happening is we have a neutron releasing an electron and became a proton. Okay? So this is what's happened there.